In this video discussion, we will demonstrate the procedure for collecting soil samples that will be used for baseline measurements of soil organic matter in the IML-CZO. We will outline the necessary equipment as well as the steps involved to collect samples while avoiding cross-contamination. Finally, we will also present some general information for sampling safety within the field. These baseline measurements will be used as input data to evaluate watershed erosion. This will be done through biogeochemical modeling to address our questions regarding transport, transformation, and storage of soil organic matter in the critical zones of intensely managed landscapes. Consistency in sampling methods is important to allow for fair comparisons among sites. Therefore, we are presenting here the procedure that will be used as the basis for collecting soil samples in the IML-CZO. The sampling procedure described herein is designed for 3 people. It is important to collect all of your sampling supplies a few days before you plan to sample. Equipment needed for sampling is outlined here. This list can also be found in your sampling protocol. For this study, we will perform a broad sampling across 6 different hill slopes in the Clear Creek watershed. We will examine 2 different hill slopes in each zone. Soil samples will be collected from the top 10 centimeters of selected hill slopes in the Clear Creek watershed to quantify seasonal changes in total below-ground carbon. These measurements will be used for developing total carbon budgets. The first step when you get to the field site is to flag your sampling locations. Samples will be taken in 4 transects on the landscape: the summit, the mid-slope, the toe slope, and the floodplain. 3 samples will be taken per transect, and these samples will be flagged 33 meters apart. At each flagged location, researcher 1 will note the following. We will now demonstrate this process. After flagging and recording the site location, researcher 1 will carefully remove any litter or organic material and place it in the appropriately labeled bag. Next, researcher 1 will collect soil moisture and temperature using a soil moisture probe and thermometer. Researcher 1 is also responsible for taking CO2 flux measurements using an infrared gas analyzer. After researcher 1 has removed the litter and taken initial measurements, researcher 2 will dig a hole approximately 1 foot wide by 1 foot deep. Researcher 2 will then expose a vertical soil surface using a spatula, disturbing the soil face of the pit as little as possible. Next, researcher 2 will take the 0 to 5 centimeter soil sample using a 5 cubic centimeter scoop. It is important to align the top of the scoop with the top of the soil surface. These samples will also be used to calculate bulk density. Therefore, it is important to collect exactly 5 cubic centimeters of sample without compressing the soil. Researcher 2 will then carefully hand the sample to researcher 3, who is prepared with foil to wrap the sample. Researcher 3 will remove all of the sample from the scoop onto the foil and fold the foil around the sample. Next, the sample will be taped and placed in the appropriately labeled bag. Finally, it will be placed in a cooler for storage. This process is repeated for samples collected from 5 to 10 centimeters. Once all of the samples have been collected, researcher 2 will fill the hole back in. Meanwhile, researcher 3 will wash all of the equipment with tap water and then DI water. With regards to every field sampling, we must work with Mother Nature to make sampling successful. However, Midwest weather is anything but predictable. Therefore, it is always better to be over-prepared. Dressing in layers and wearing waterproof gear are 2 easy ways to stay ahead of the weather. The final outcomes of this sampling procedure will be soil samples that can be used for quantifying not only the amount of organic matter in the soil, but also the bulk density, particle size, other nutrients such as nitrogen and phosphorus, the concentration of stable and radioisotopes, as well as geophysical properties for identifying sediment provenance. The list of analyses you will perform will dictate the steps for sample preparation. This will be covered in subsequent videos. Thank you for your time and good luck sampling.